This is part 2 of the summary of Statway Module 2. So we left off talking about the median, and the median is in the center of the data, 50% below the median, 50% above the median. Well, there's something called the 5-number summary. The minimum is obviously the minimum value, and the max is obviously the maximum value. Now, right here, between 33.9 and 45.1. That's a divider that divides the first quarter of data. Now there are 12 numbers, so there are 4 quarters of data, not quartiles, quarters. So the first quarter of data consists of 3 numbers. The second quarter of data consists of 3 numbers. The third quarter consists of 3 numbers, and the fourth quarter consists of 3 numbers. Now, Q1 is called the first quartile, and that is the number that separates the first 3 numbers, the first quarter, from the next 3 numbers, the second quarter. Now in this case, in order to get it, we don't have a number in between, so we have to average the 33.9 and the 45.1. And right over here, that gives us 39.5. Now, we don't want to actually have to go through and do this by hand. So luckily, we can do this on our TI. Now, the first bar here is called the first quartile. The second bar right here is the median. The third bar is called the third quartile. That separates the third quarter of data from the fourth quarter of data. So 25% of the data is in the first quarter, in the second quarter, the third quarter, and the fourth quarter. Now, we'll take a short break and let me show you how to do this on the TI. Okay, so now we want to be able to get the values that we have for the 5-number summary by using the TI. So using the 12 values for temperature in St. Louis, I have now gone into my TI and I have entered them into L1. So remember how to enter it. You hit the Stat button, you have Edit, you hit Enter, you come to L1 and enter the numbers. Now, in order to get the 5-number summary, go back to Stat, move your cursor to the right to Calc, and just like we did for the mean and standard deviation, 1 var stats. L1 is the list we're using. Now notice at the top, it did compute the mean and the standard deviation. N is 12. There are 12 numbers. Now, if we scroll down, look what we have. We have the 5-number summary. The min is 29.9, Q1 is 39.5, median 57.55, Q3 72.8, and max 79.8. And we come back and check what we had on our TI versus what we have for the 5-number summary for this problem, and sure enough, they match. Okay, the next thing is down below, this graph right here. This is called the box plot. It's also called the box and whisper plot. The purpose of this is to graphically display the 5-number summary. Now, all the way out here on the left is the minimum value. This first vertical bar is your Q1. Your next vertical bar is your Q2, which is your median. This is Q3, and this right out here on the right is your maximum. Now, in each part of this, the first whisker here holds 25% of the data. This first rectangle on the left, 25% of the data. This rectangle here, 25% of the data. And this last whisker, 25% of the data. Now, how do we measure variability in regard to the median? It's something called the IQR. It is Q3 minus Q1. It is the length of these 2 rectangles here. The IQR holds 50% of the data, 25% from here, 25% from here. And the IQR is a measure of variability. it is very resistant to outliers. So again, how do you get the IQR interquartile range? You take your Q3 value minus your Q1 value. And between those two numbers, you have 50% of the data. So in this case, the IQR is 72.75 or 72.8 minus 39.50, which is 33.25. So 50% of the data is within a very wide range, and you can see that the IQR is large. To have less variability, you would want those two rectangles to be as short as possible. The longer the rectangles are, the larger the IQR is, the more variability you have in your data. Now, how do we determine if there are any outliers? There are two things called fences, as you can see in this picture below. What you do is you take Q1 and you go to the left. You subtract 1.5 times the IQR. That gives you a lower fence, a lower boundary. You take Q3 plus 1.5 times the IQR. That gives you an upper fence. So in our case, the lower fence is negative 10.375. The upper fence is 122.675. If there are any outliers, they will either be less than the negative 10 here or bigger than the 122. There are no data values in our case. Less than minus 10 or bigger than 122. So you don't have to have outliers. Now, in this example down here, any point that lies either to the right of the upper fence or to the left of the lower fence is considered an outlier. We said the IQR is resistant to outliers. So we've talked about center, we've talked about spread, let's talk about shape. Well, skewed left. When you have something like this, where you have some data to the left and it's not symmetric, that is called skewed left. When you have something like this, you have data to the right of the center, that's called skewed right. Uniform distribution is everything has the same number of data. And bell-shaped distribution, that's our normal curve, that's what you really aspire to. Now, in a skewed left distribution, if the median is right around here, the mean is influenced by these smaller values. When you have something skewed left, the mean is pulled away from the median to the left. The mean is always pulled in the direction of the skewing. Over here, skewed right. Again, the mean is pulled away from the median in the direction of the skewing. So it's pulled to the right. So in this case, the mean is bigger than the median. In this case, the mean is less than the median. Okay, and finally, our last set of examples. Let's look at the histogram on the left. Suppose we wanted to estimate the median. Okay, well, the first thing is it's skewed left. Okay, so we know that we're going to have a mean less than the median. But let's say we just want to get the median. Okay, now look at the frequency. Let's count up how many data values we have. 1, plus another 1 is 2, plus another 2 is 4, plus 3 is 7, plus 4 is 11, plus 5 is 16. We have 16 data values. The median is going to be in the middle. It'll be 8 below, 8 above. So let's count until we reach 8 data values. 1, 2, 3, 4, 5, 6, 7. So the median is probably just a little bit above 4. So now if we're trying to match up one of the box plots on the right with the histogram on the left, our best guess is probably going to be A. Because here we're thinking 4 to 5 is probably going to be the median. Okay, so we'd eliminate the top 2 here. And let's see, what about Q1? Well, Q1 is after you have 4 data values. 1, 2, 3, 4. So that brings us to about 3 or so. So 3.5. That seems about reasonable. And finally, nothing but good things happen with a larger sample size. You want your sample size to be as large as possible.